Hello everyone, welcome back to part 2 of NSEP PYQs solutions of the chapter Work Power Energy. In the first part we covered the first 5 questions, and from in this part we'll be covering from question 6. So let us begin. The first question says that a particle moves in a straight line under the action of a constant force. Then the graph of power developed by the force against. So we have to find the nature of the graph of power plotted against time and displacement, and we have to comment on the shape. Okay, so first of all, we are given that the force is constant, and we know that power can be given as force multiplied by velocity, right? Because power is equal to work done per unit second, which means work done divided by time in seconds, right? And work done is force into displacement by time. So this becomes force into velocity. Okay, so now we know that F is constant and we need to get a relation between power and time. So since force is not varying with time and velocity is varying with time, I'll write velocity in terms of time. We know that V can be given as initial velocity plus acceleration times time. So I'll put this V here, which will give me P is equal to Fu plus Fat. So this is a linear graph, right? Y is equal to C plus mx, right? Where x is t, so I should x is t and y is p, right? And m is the slope, which is f times a, and c is the constant fu. Okay, so this is a straight line. So option A is correct, and since this is a 6 marker, so it has many options correct. So let us check the displacement option also. So displacement can be given as, so we have two formulae for displacement. S is equal to ut plus half at square. But this one does not have v, the velocity at any time. It only has time and the initial velocity and acceleration. So we won't be using this formula. Instead, we'll use this formula. V square is equal to u square plus 2as, which will give us S as v square minus u square by 2a, right? Sorry, we need to find v in terms of S. So this will give us v is equal to square root of u square plus 2as. So power will become equal to force time u square plus 2as, right? If we square both sides, we'll get p square is equal to f square u square plus f square 2as, right? So this is of the form y square is equal to something x plus something constant, right? So this is the equation of a parabola. Hence, the displacement versus the power versus displacement graph will be a parabola. So option A and D are correct. So the question 7 says a body of mass 4m at rest explodes into 3 fragments. Two of the fragments, each of mass small m, move with speed v in mutually perpendicular directions. So the total kinetic energy released in the process is asked. Okay. So initially we have a mass of 4m and it explodes into 3 fragments, m, m, and these two are given. So the third mass must be 2m, right? Due to mass conservation. And we can conserve the momentum here because there is no net external force. The only force is the internal force which is causing the explosion, but the internal forces will follow the Newton's third law and they will be equal and opposite on all the fragments, so they will cancel out. So there is no external force, so momentum is conserved. Now the two masses which have the mass small m, they are moving with speed v in mutually perpendicular directions. So let me take in I and j direction. So now I'll start conserving the momentum. So momentum of this particle is mv in I direction. This is mv in j direction. And this is 2m v dash. We don't know the direction, so I am just writing v dash as a vector. And this should be equal to the initial momentum, which is 0, as this has 0 velocity. So from here we can get that v dash would be equal to minus v I cap minus v j cap by 2, right? Because m will get cancelled. So now we have v dash, and we have to calculate the kinetic energy of all three particles. So this particle will have half mv square. This other particle will also have half mv square, right? And this particle will have half into 2m into v dash ka square. Now v dash square can be obtained in two ways. First is simple dot product. So v dash dot v dash. So this will be minus v I cap by 2 minus v j cap by 2 dot product with minus v I cap by 2 minus v j cap by 2. So I cap will go with I cap because I dot j is 0. So this will become v by 4, and this will also become v by 4. So v square is essentially v by 2, right? Also we can obtain v square in another way, because we know that the square of a vector is equal to the square of its magnitude, right? So first we need to find the magnitude, which we can find using the this formula, that a plus b magnitude is given by a square plus b square plus 2ab cos theta. So magnitude of v can be found, magnitude of v dash can be found out by applying that formula. So if we write this as minus v I cap by 2 minus v j cap by 2, so this can be taken as a and this can be taken as b. So a square would be v square by 4, b square would be v square by 4, and 2ab cos theta will be 0 because the theta between I and j is 90 degrees and cos theta is 0 for 90 degrees. So magnitude of v dash is equal to v by root 2. So v dash square is equal to magnitude of v dash square, which is equal to v square by 2, right? This was also v square and v square. Sorry. So we have gotten the same from both the methods. So now we can calculate the final kinetic energy. So 2 into half mv square plus half into 2m into v square by 2. This 2 and 2 gets cancelled, this 2 and 2 gets cancelled. So this is mv square plus mv square by 2, which is 3 mv square by 2. So the answer is option B. So moving on to question 8, it says that simple pendulums P1 and P2 have different lengths, 80 centimeter and 100 centimeter respectively. So the bobs of the pendulums have different masses, small m1 and small m2, and initially both are at rest at equilibrium position. So equilibrium position is this position when the string is straight, because in this position the gravity is balanced by the tension in the string, so it is in equilibrium. If each of the bobs is given a displacement of 2 centimeters, the work done is W1 and W2 respectively. Then so we have to compare W1 and W2. So in this question we have been given a displacement and we need to find the work done. So work done depends on the vertical height, right? But the displacement is not the vertical height, because imagine if the pendulum is now like this after the displacement. So the displacement, which is 2 centimeter, let us represent it by d, it is this. But this d does not come in the formula of W, right? Height comes. So we need to find this height, right? Okay, so if this is theta, then this height can be represented in terms of this length. So initially the string was L distance downwards from this point, and after that it became L cos theta downwards, right? So this height can be given as L minus L cos theta, because this distance till here is L cos theta, right? So this will be the subtraction of L and L cos theta, right? So this will be L 1 minus cos theta. Now this displacement is very small, so this theta is also very small, right? So in such cases we tend to approximate all the terms as sine or tan, because in sine and tan the theta can be separated from the function, because this will be L 2 sine square theta by 2, and since theta is very small, so sine theta can be approximated as theta if theta is very small. So height will become 2L theta square by 4, which is L theta square by 2. Now this theta we need to represent in terms of what is given, which is displacement, and this length. So since this is very small, this can be approximated as an arc of a circle, and the arc of a circle is given as the angle contained by it and the radius. So radius is L and angle is theta. So this will be, so from here we will get that D is equal to L times theta, which gives us that theta is equal to D by L. So height will become equal to L times D square by 2L, which is, sorry, this will be L square. So this will be D square by 2L, right? So work done will be equal to mass into gravity into height, which is mg D square by 2L. D and L are given, and M and M we have to decide, right? So work 1 would be equal to mg, D is given as 2 centimeter, so 4 by 2 L, right? So L1 will be 80. So for now I am ignoring the centimeter and meter because we are only concerned with the ratio. So W2 would be mg times 4 by 2 into L2 is 100. So first option says that W1 is greater than W2 if M1 is equal to M2. So that is correct, because if M1, this would be M1, this would be M2. If M1 is equal to M2, then W1 is greater because the denominator is smaller. So option A is correct. Option B is incorrect because option A is correct. So when will W1 be equal to W2? So for that, M1G is equal to M2G times 4 divided by 2 into 80. Cancelling out the common terms, we get M1 by M2, sorry, this was 100. M1 by M2 is equal to 80 by 100, which is 4 by 5. So M1 by M2 should be equal to 4 by 5. So option D is correct. So option A and D are correct. This was a nice question because some people might get confused on how to separate, how to get this as a function of theta and how to write that theta as a function of this displacement. So this was a nice question. So moving on to question number 9. It says that assume that a constant power capital P is supplied to an electric train and it is fully used in accelerating the train. So we need to obtain relations giving the velocity of the train and distance traveled by the train as a function of time. So power is given as F dot V, and power is constant. It is specified that constant power is supplied. So velocity and force will be changing, right? Because there is an acceleration, and so we can write this force as mass times acceleration. And since we need to find velocity as a function of time, so we need to write that acceleration as dv by dt, right? So P is equal to mass times dv by dt times v, which will give us P by m dt is equal to dv dot v. Now we can integrate this. So if we assume that at t is equal to 0, velocity was 0, and at t is equal to t, it is v. So P by m times t is given as v square by 2, which gives velocity as 2pm multiplied by t whole root. So this is the relationship between velocity and time. Now we need to find the relationship between distance traveled by the train and time. So we can write this v as ds by dt, which will give us this relationship. So ds can be written as, I'm writing this as t raised to power half so that it is easy to integrate. Similar integration as we did above will give us s is equal to root 2p by m. This will become t raised to power 3 by 2 divided by 3 by 2. So this is the relationship between s and t. So this question is very common nowadays in the JEE circuit. So the next question, question 10, says that a force capital F is acting on a body and it is dependent on its displacement s as s raised to power minus 1 by 3. So we need to find the power delivered by the force as a function of its displacement. Okay. Force is given proportional to s raised to the power minus 1 by 3. And we know that power can be given as force times velocity. So we cannot directly say that the power would be proportional to s raised to power minus 1 by 3 because the velocity also might be a function of displacement, right? We can check that because F is given as, so F would be given as mass into acceleration, which is equal to m multiplied by v dv by dx, right? Acceleration can be written as v dv by ds. I should write displacement as s. So this is proportional to s raised to power minus 1 by 3. So from here, rearranging the terms, we'll get mv dv is proportional to s raised to power minus 1 by 3 ds. So integrating on both sides, we will get mv square by 2 is proportional to s raised to the power 2 by 3 divided by 2 by 3. So we can see that velocity is a function of, if we take this 2 here, velocity is proportional to s raised to power 1 by 3, right? So finally, power would be proportional to s raised to power minus 1 by 3 dot s raised to power 1 by 3, which gives us s raised to the power 0. So this is an interesting observation that if force is proportional to s raised to power minus 1 by 3, then the power won't be dependent upon the displacement. So the correct answer is option D. This was a nice question.